Good morning, guys. We're going to go ahead and get started with lesson 9. Today is Tuesday. The objective for today tells us I can understand that a ratio table is a table of equivalent ratios. I can use ratio tables to solve problems. So today we're going to kind of go back to making ratio tables. We know that ratio tables are a table of equivalent ratios. Okay, and we're going to use these tables to solve problems. Okay, so look at example number 1. To make paper mache, the art teacher mixes water and flour. For every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. Find equivalent ratios for the relationship 2 cups of water to 3 cups of flour. Represent the equivalent ratios in the table below. Okay, so our ratio here we know is 2 to 3. Okay, so our table is 2 to 3. Make sure you have some paper with you. Go ahead and complete the table on your own. Pause the video. Okay, and when you're done, go ahead and start the video up again. Okay, so you should have completed the table. This would be 4 to 6, 6 to 9, 8 to 12, and 10 to 15. Okay, so that is our table of equivalent ratios. All those ratios have the same value. Okay, they all have the same value, and our value here is 2/3. Okay, that's our value. All of these have the same value. So let's look at the questions on the side. It says, what does the ratio mean for every 2 cups of water there are 3 cups of flour? Well, what that means is that they're going to come together. Okay, so every time I put in 2 cups of water, they're going to put in 3 cups of flour. Okay, that's what that ratio means. Why is it worded for every 2 cups of water, there are 3 cups of flour? Well, this suggests that we might be doing that action repeatedly, adding 2 cups of water and 3 cups of flour. Why would I do it more than once? There are times that you're gonna have to make batches that are larger than using 2 cups of water and 3 cups of flour. And that's why if you need big batches, that's why we have a table of equivalent ratios that give us the exact value that we need if we're gonna make bigger batches of this paper mache paste. Okay? So what is the value of each ratio in the table? We already said that our value is 2/3, okay? Is that what we expected? Yes, because we started off with 2 to 3. Okay, that's our first original ratio, and it's in lowest terms as well. Okay? Let's move on. So this one says Javier has a new job designing websites. He is paid at a rate of $700 for every 3 pages of web that he builds. Create a ratio table to show the total amount of money Javier has earned in ratio to the number of pages he has built. Okay. So total pages, we know his ratio is, they want us to make it, the ratio shows the total amount of money Javier has earned in ratios to the number of pages he has built. Okay, so our ratio is 700 to 3. Okay, for every $700, he makes 3 pages of web content. Okay, so I'm going to put 3 for total pages built, and total money is 700. Now I want you to complete that table. Pause the video, okay, and then try to answer the question below. Okay, go. So you should have paused the video and completed the table. One side's counting up by 3s, okay? And the bottom's counting up by 700s. It's easy to just count up by 7s and then just add 2 zeros, okay? Good. So it says Javier is saving up to purchase a car that costs $4,200. How many web pages will Javier need to build before he can pay for that car? Well, looking at our table, let's find 4,200. It is right here at 18. So he would need 18 web pages. Okay? And that is how we're using a table to answer our questions. Okay? A table of equivalent ratios. All right. So it says, is there an equivalent ratio to 700 to 3 that uses smaller whole numbers? Okay. No, because there's not going to be a whole number smaller than 3. Okay. There's going to be a number that has a decimal that's smaller than 3, but not whole numbers. And we'll get into that later. Okay. But for now, the answer is no. All right, exercise 1. Spraying plants with cornmeal juice is a natural way to prevent fungal growth on the plants. It is made by soaking cornmeal in water, using 2 cups of cornmeal for every 9 gallons of water. Okay, so we already know our ratio here, 2 cups of cornmeal for every 9 gallons of water. So our ratio is 2 to 9. Complete the ratio table to answer the following. Okay, so cups of cornmeal, 2 gallons of water, 9. Okay, so now complete the table. Pause the video, complete the table real quick. Should have paused the video. Okay, your table should look like this. One side's counting up by 9s, the other one's counting up by 2s. Okay, look at letter A. How many cups of cornmeal should be added to 45 gallons of water? Well, we find 45. And how many cups corresponds with 45? 10 cups. Okay? Now, Paul has only 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice as he can? Okay, he has 8 cups of cornmeal. So how many gallons of water does he need? Correct, 36. Good. And letter C, what can you say about the values in the ratios, in the ratio tables? All of these values, what can you tell me about them? They are all equivalent, okay? Okay, same value. All 2 over 9, because that's our value in least common terms. Okay, let's move on. Exercise 2. James is setting up a fish tank. He is buying a breed of goldfish that typically grows to be 12 inches. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water per fully grown goldfish in the tank? Complete the ratio below to help the ratio table to help answer the following questions. Okay? So, since his goldfish is 12 inches long, okay? For every one fish, he's going to need how many gallons? Okay? It's telling us that 1 gallon of water for every inch of fish. So if a fish is 12 inches, one fish is going to need 12 gallons. Okay? So our ratio here is 1 to 12. So now let's complete the table. 2 to 24, this is pretty easy. 3 to 36, 4 to 48, and 5 to 60. Okay? So what size and tank is needed for James to have 5 full-grown goldfish? Well, we look at the 5 full-grown goldfish, and he will need a 60-gallon tank. Yeah, that's a huge tank. How many full-grown goldfish can go in a 40-gallon tank? Okay, well, 40 is going to lie somewhere between 3 and 4, okay? 3 and 4. So 4 needs 48 gallons of water, okay? So in a 40-gallon tank, only 3 full-grown fish, goldfish, can survive, okay? Because it's a little bit higher than 36, okay? But it's not there quite yet, so it can't be 4. So what can you say about the values of the ratios in the table? What are the values of these ratios? Okay, they're all equivalent. And the value of all of them is all 1 over 12. Okay, 1/12. Okay, so they're all equivalent. Good, a lesson summary. A ratio table is a table of pairs of numbers that form equivalent ratios. You know how to do ratio tables. You know how to find problems and answers using ratio tables. You know how to complete ratio tables. Okay, so this lesson should be no problem for you. All right, if you have questions, let me know. You're going to get a problem set that looks like this. All you're doing is finding the missing values in the ratio tables. Okay, think critically. If you have questions, let me know. All right, and have a great day.